Hi friends, in this video we are going to discuss about this particular problem. So the question is, find the value of total current. Just see here, find the value of total current in the following network. Okay, so this is the network we are having and our target is to find the total current. It means how much amount of current is flowing in this particular network we need to find. Okay, so here what is the formula we are using to calculate the value of current? Actually, the formula we are using is I is equal to V divided by R. Okay, so this formula we can directly use to find the value of current. Here he is asking total current. Total current means I am assuming, so IT is the total current and here IT is equal to VT divided by RT. Okay, so here VT represents the total voltage. So VT represents the total voltage applied, divided by RT means total resistance in the circuit or network. Okay, so this is the formula we are using to calculate the value of total current. Okay, now see here, total current IT is equal to VT. VT means how much? We are applying here 100 volts. It means directly we can say that the value of VT is equal to 100 volts divided by RT is how much? RT, we don't know exactly what is the value of total resistance or equivalent resistance in the given network, because we are having totally 7 resistances are there. So in order to find this total resistance, we can go for the series and parallel combination of resistances. Okay, so if you are going to use the series and parallel combination of resistances concept, then finally you are going to get the total resistance, that is equivalent resistance from the given network. So in order to find this particular total current, first we need to get the total resistance from this particular circuit or network. Okay, so for that what we need to do, first we need to find this particular value of total resistance. Now whenever we are going for the calculation of total resistance, first we need to observe in the given problem whether the voltage source is connected in the left side or right side. Now we can say that in the given problem the voltage source is connected in the left side. So when the source is connected in the left side, then you can find the value of total resistance, or that is equivalent resistance, start from the right side. Because if you are going to start the calculation of total resistance again from the left side, when the voltage source is connected in the left side, then it is not possible to find the total resistance. That is the reason why if the source is connected in the left side means you can start reducing or you can start calculating the value of total resistance from the right side. Okay, now see here in this particular problem, now R6 and R7, see here, so here R6, this R6 and R7 both are connected in series. Okay, so R6 and R7 both are connected in series initially. Now first we need to get this particular equivalent value. Okay, so now in this problem, so R6 and R7 are connected in series. Now first we need to find the resultant of this series connection of R6 and R7. Now here for that what I am doing, so R6 and R7 are connected, or these resistances are connected in series. So these two are connected in series. Now how to find the series connection of resistances? If both are connected in series means we can directly find the total resistance of this series connection by adding these two values. That is total resistance of this series connection of R6 and R7, it will give RT is equal to R6 plus R7. Now we know that the value of R6 is 12 ohms plus the value of R7 is 16 ohms. Now it will gives the value as 12 plus 16 means you will get 28 ohms. Now this is the value of equivalent of a series connection of two resistances. Okay, now what I am doing, instead of the R6 and R7, now I am going to replacing this value. Now see here, again I am redrawing this particular circuit like this. Now see, so this one R1 is equal to 2 ohms and R2, this is R2, so R2 is equal to, this one is 4 ohms, and coming to this one, so R3 and R4, R4 both are connected in parallel, and this one is the R5, this one is the R5, so this one is R3 and this one is R4 and this one is the R5. Now instead of R6 and R7, I am going to use this particular resultant value, that is 28 ohms, instead of the series connection of this particular series connection. So here we got the value of equivalent resistance as 28 ohms, and the value of R5 is equal to 10 ohms, and the value of R4 is equal to 8 ohms, and the value of R3 is 6 ohms, and applied voltage V is equal to 100 volts. Okay, now after substituting this particular, or after replacing this 28 ohms, now see here, 28 ohms and R5 both are connected in parallel. Now these two are connected in parallel, so that is the reason the total resistance or equivalent resistance given by these two particular values is given by, the value of R5 is 10 ohms and the resultant of this one is 28. Now both are connected in parallel means, now how we can get the value of total resistance? So 10 into 28 divided by 10 plus 28. Here 10 into 28 means 280 divided by 10 plus 28 means you will get 38. So if you are going to simplify this value, 280 divided by 38, you will get the value as 7.368 ohms. Okay, now this is the resultant of parallel combination of R5 and 28 ohms. Now I am going to replacing this particular equivalent value instead of the parallel combination of R5 and 28 ohms. Now see here, I am redrawing again the network here. So this is voltage source, this one is voltage source, and here R2 is connected, and this one is R4 and R3 both are connected in parallel, and here the resultant of this particular, the resultant of R5 and R8 we got as 7.368 ohms. So that is the reason why instead of this parallel combination I am directly placing this particular resultant value, that is 7.368 ohms, and we know that this R4 is equal to 8 ohms, R3 is equal to 6 ohms, R2 is equal to 4 ohms, R1 is equal to 2 ohms, and this voltage source V is equal to 100 volts. Okay, now see, after getting this particular resultant, now see, R3, R4 both are connected in parallel, and whatever the resultant we will get, so that particular resultant value connected in series with 7.368 ohms. So for that, what we are doing, first we need to find the value of the parallel combination of R3 and R4. So here parallel combination of R3 and R4 are given by, so here the total resistance of parallel combination of R3 and R4 given by, so product of R3 R4 divided by R3 plus R4, that is equal to R3 is how much? R3 is 6 ohms into R4 is how much? 8 ohms. So 8 divided by 6 plus 8. Now this RT, total resistance of parallel combination of these two, it will gives, so you will get 6 into 8. 6 into 8 means how much? 48 divided by 6 plus 8 means how much? 14. So here 48 divided by 14. If you are going to simplify, you will get the value as 3.428 ohms. Okay, so this is the resultant of what? Parallel combination of R3 and R4. Now, instead of this parallel combination of R3 and R4, again I am going to replacing the value, resultant value of 3.428 instead of the parallel combination. Now I am going to redrawing the network like this. Now see, now so this one is R1 having a voltage source of 100 volts. R1 is equal to 2 ohms, and here this one is R2. This one is R2. So R2 is equal to 4 ohms, and here the parallel combination. Okay, here the parallel combination of R3 and R4, we got the value as what? 3.428. Okay, this one, just see here, the resultant of this one, we got 3.428. Now instead of this parallel combination, I am directly using this value 3.428 ohms. Okay, now again the another resistance, that is the value of 7.368 ohms is there. Now see, now these two are connected in series. Now find the value of resultant of these two. So here 3.428 ohms and 7.368 ohms, both are connected in series. So are connected in series. So if two resistances are connected in series, means to get the resultant, just we can directly add these two values. So total resistance of this combination is 3.428 plus, so 7.368. If we are going to adding these 2 points, that is 3.428 plus 7.368. if you are going adding, then you will get the resultant RT is equal to 10.796 ohms. Now this is the resultant of what? The series combination of 3.428 ohms and 7.368 ohms. Now again I am going to replacing this total resistance instead of this series combination. So here again I am redrawing the network like this. Now, so this one is the 100 volts. This one R1 is equal to 2 ohms, and here R2 is as it is we are placing here, that is R2 is equal to 4 ohms. Now instead of this series connection of this one, I am directly substituting the value of resultant as 10.796 ohms. Okay, now again see this 10.796 and R2 value both are connected in parallel. So if two are connected in parallel, then how we can find? So here R2 and 10.796 ohms both are connected in parallel. If both are connected in parallel, to get the resultant of these two, so we can directly use product of these two values divided by addition of these two values. So 4 into 10.796 divided by 4 plus 10.796, that is equal to here 4 into 10.796, it will gives the value as 43.184 divided by 4 plus 10.79 means, so 14.796. Okay, now if you are going to simplifying this one, 43.184 divided by 14.796, if you are going to simplifying this one, so you are going to get the total resistance is equal to 2.918 ohms. Now this is the resultant of what? Parallel combination of R2 and 10.796. Now again I am going to replacing this total resistance in the actual network. Now see here, again I am redrawing this given network. Now see, so this one R1 is equal to 2 ohms, and instead of this parallel combination I am replacing with this value, that is 2.918 ohms. Now this one is V is equal to 100 volts. Now R1 and 2.918 both are connected in series. Okay, now series. Now the total resistance in the given problem RT is equal to R1 plus 2.918 ohms. Now here R1 is 2 plus this value is 2.918 ohms. Now finally you are getting 4.918 ohms is the final resistance, that is this is the total resistance in the given network. Okay, now finally you got the value of total resistance in the given problem. Okay, now whatever the given circuit is there, so in this particular given circuit, so we are having the total resistance as 4.918. now after getting this value, now go for the calculation of total current. So our question is to find the total current in the given network. So here, total current IT. Okay, so total current IT from the given network, that is equal to, total current IT is equal to VT divided by total resistance RT, that is equal to V2 is how much, 100 volts we are applying, RT is how much, 4.918 ohms. Now if you are going to simplifying this one, 100 divided by 4.918, if you are going to simplify, then you will get the current flowing in the given circuit is 20.3334 amps. Okay, so this is the total current flowing in the given network. Okay, so thank you so much for watching, and please do subscribe my channel. Thank you.